Hello, it's me again. Graphing. So, pause and copy. Now, I'm giving you the first and second derivatives to save time, but also I want us to focus on the interpretation of derivatives and not the finding of derivatives. Okay, part A is domain. So our original function has no restrictions. Okay, you have this 2/3 exponent, which is not a big deal. You can write that as third root followed by a squaring. Now, square roots, there are problems with square roots, but not with cube roots. Cube roots do not have restrictions. So the domain is all real numbers. B. Intercepts. So we take our function, set it equal to 0. To find the y is 0, so x intercepts. And from here we get x is 0. And from the bracket we get x is 5. So that yields the point 0, 0. And this one yields the point 5, 0. Okay, so for the y-intercept, you set x equal to 0. So f of 0 is going to be 0. So from this, again, we get the origin again. Part C is symmetry. We're going to skip that. This one will turn out to not have any symmetry in any case. D, asymptotes. So f of x is equal to x is 2/3, x minus 5. Now, this function never shoots up to infinity or down to minus infinity. There's no chance of a division by 0. So we'll write that. No asymptotes. Since, as we said, no vertical asymptotes, but also when I do my two limits, x goes to infinity, x goes to minus infinity. Okay, I'm not going to get real numbers in either case. It will be useful to see what I do get. So x goes to plus infinity. So I get infinity times infinity plus infinity. And then if I'm going to minus infinity, I get minus infinity here. This guy's a bit trickier. I got the power of 2 here, which is going to turn any negative x into a positive. So minus infinity times plus infinity. Overall, I'm getting minus infinity. So no asymptotes, but these calculations are useful. E, intervals of increase and decrease. F prime of x is, let me grab it from above here, x minus 2, 3x to 1/3. Okay, so f prime of x, to find a critical number, set it equal to 0. And what do you get? You get that x must be 2. And f prime of x does not exist. What does that give me? That is when you have division by 0 here. So x equals 0. Now these are both critical numbers because, well, this one's obvious why it's a critical number. This one, x equals 0, makes the derivative not exist, but it is in the domain of the original function, which was x to 2/3 x minus 5. Okay, 0 can be plugged in here. So that makes x equals 0 a critical number. So for the intervals of increase and decrease, we have put our 0 and our 2 on a number line. And then we do test points. So I choose a number over here, plug it in there. So say -6. I'm getting negative over negative, giving me positive. So increasing here. And then if I choose 1, the number 1 here, I'm going to get negative over positive, overall giving me negative. And then finally, if I choose, say, the number 3 over here, plug it in here, you get positive over positive. So it's increasing. Again,